All right, so 3.2. What do we know? We know that we've talked about average rate of change and instantaneous rate of change. I think it would be really important to be able to look at the diagrams for these and the formulas, right? And make a strong connection between the diagrams and the formulas. All right. So that's, like I said, it's one of the most important concepts here. And it's something I really want us to be able to explain and find. So average rate of change and instantaneous rate of change, definitely super important. Okay. And so what's new in this section? As promised, these two sections are a little bit shorter than maybe some of the other ones that we've done. So what's new here is we're going to take a look at something called the formal definition of a derivative. Okay. Now, when we get to exam 2, all right, so this is for exam 1, all right. Exam 1, you should expect to see this idea of a formal definition of a derivative. However, beyond that, then we're going to have other ways, less formal ways of finding a derivative. Okay, and so the key word here would be formal, and making sure that we know sort of where the different pieces come from and how we can execute the procedure behind that. Okay. So let's get started. The formal definition of a derivative. All right, so this is a little review of what we just covered, but I think it'll be helpful when you come back and maybe study this, a little bit further out. So we can find the slope of a secant line. All right, so secant line, also known as that average rate of change, using our f of b minus f of a over b minus a. Okay, so that's something that we did in the beginning of 3.1. Then we sort of move to this idea that if we select 2 points, x, f of x, and x plus h, f of x plus h, and we choose them specifically to be really close together, what that allows us to do is approximate the slope of the tangent line. So again, tangent line meaning 1 point, using this formula. Okay. This limit happens so much in calculus that we give it a special name, a derivative. Okay, so this limit that we have here happens so much in our course that we give it a special name and we call it a derivative. Okay, and so here we have our formal definition of the derivative. Okay, the derivative of f of x with respect to x has some symbols with it. Okay, and in particular, we can write this as f with a little apostrophe. We call that f prime. Okay, so f prime. And we define it as the simplified version of that limit. And simplified meaning that this h used to be x plus h minus x. Okay. So this formal definition of a derivative is another way of asking us to find the instantaneous rate of change. All right. Vocabulary is so, so important here. And I want to make sure that we feel really good about not just, okay, this is this and that is that, but which ones are almost like synonyms for each other. Okay, which ones are other ways of saying the same thing. Okay. let's maybe even make a note here that this is the same as the instantaneous rate of change. Okay. All right, so let's go ahead and we'll get started and work through a definition, okay? So here we have for the function f of x equals x squared. And let's see, will we be using them interchangeably? Yes, we will be using them interchangeably, which is why I want to make sure we know how to, all the different ways of saying it, okay? Primarily, we use derivative, but we could also use average or instantaneous rate of change, and I would want us to know what that means, okay? All right, so you find the derivative using the formal definition of the derivative, okay? And so what we're going to do here is we're going to simply take our formula right up here and we're going to copy it down right over here. Okay. So we can say that f prime of x equals the limit as h approaches 0. What does that part mean again? Like, why do we have the limit as h approaches 0? Because h is a really small number. And why is h a really small number? Like, because we designed it that way, but why is h a really small number? To get as close as possible to that first point. Exactly, exactly. Okay. Then we have a fraction business. We have f of x plus h minus f of x all over h. Okay. And this came from our slope formula between 2 points, right? So the limit as h approaches 0. How can I, if I know that my function is x squared, what is f of x plus h? Like, how do I write f of x plus h? F of x squared plus h, like this, f of x squared plus h. Okay, what do we think about that, folks?
You have to square both x and h.
Oh, so you mean like this?
Like as a quantity. X plus h quantity squared.
Oh, okay. So I'm going to actually erase this. I'm going to put this off to the side and let's kind of discuss how we find our f of x plus h, okay? So I'm wondering if I have f of 1 and I'm using this function f of x equals x squared, what is f of 1? Okay, and how did we get that? I agree that it's 1, but how did we get 1? We did 1 squared and that got us 1, right? Okay. What about f of 2? We get 4 because it's 2 squared equals 4, right? So whatever our input is, we're going to take that and we're going to square it. So if our input is 1, we do 1 squared. If our input is 2, we do 2 squared. If our input is x, what do we get? Yeah, x squared, right? Because we take our input and we square it. What about this? What is my input here? My input is x plus h. So guess what I have to do? I have to do exactly like Sophia and Luca said. I have to take my input and I have to square it. Okay, so I'm going to put x plus h squared. So this is my input, and I have to square the whole thing. Now, I really appreciate that we are already expanding this. Is this correct? X plus h squared equals x squared plus h squared. True or false? Okay. I love how emphatically we are saying no, right? This is probably the number one mistake. I know we know how to FOIL, but sometimes in the midst of a larger problem, we just forget, okay? Unfortunately, we're reaching a point where it's not really okay anymore to forget some of these small things, okay? In fact, because forgetting some of these small things means that it's going to impact our final answer in a way that it's in the middle of a bigger problem. So a small algebra mistake means you're going to get completely the wrong answer. Okay, so we need to be really careful about this and make sure that we FOIL this out. Okay, and that one, we can say yes, that would be how that works. Okay. And so what we're going to do right here is we're going to be really organized about our work. Everywhere we see f of x plus h, I want to see us write x plus h squared. Okay. And everywhere we see f of x, we're just going to put x squared. So my numerator becomes x plus h squared minus x squared. I like to put parentheses around this because sometimes I have more than one term here. And if I have more than one term, I better remember to distribute that minus, right? And so if I put parentheses there, it will remind me that I'm going to need to distribute. So what do we have here? We have our f of x plus h. That became x plus h squared. And we have our f of x, and that became x squared. Okay. Now, if we plug in 0 here, all right, we're going to get x squared minus x squared over 0, or we're going to get 0 over 0. And we've seen that before. If we get 0 over 0, that's a problem for us. And so what we need to do is work to write this in a different way. And what happens is we're really going to need to expand this and then simplify. Okay, so in terms of handling this 0 over 0, it's not going to be as complicated as it was for limits. All right, and so let's see what I mean by it's not as complicated. Well, everywhere I see x plus h squared, I'm going to replace it with the FOILed out version, x squared plus 2xh plus h squared. So x squared plus 2xh plus h squared is the expanded version of what was in the purple, minus x squared, which was the thing in the yellow, all over h. Okay. So do we need to sub at this point before expanding, like plug in the 0, you mean? Yeah, so if we did plug in the 0, we get the undefined, right? And that's going to be problematic for us. Okay, so we do substitute, but then we see that it's not going to work. Yeah, I do want to see that part. Just plug it in and show me that it's going to be not something that gives us what we want, okay? So we expand a little bit. We might notice that this positive x squared and that negative x squared cancel. And what do we get? 2xh plus h squared over h. Okay. Now, here's a good clue that you're headed in the right direction. Can you factor an h out of the top? Yes, okay. If you cannot factor an h out of the top, you did something wrong previous to that step. Okay, I know that sounds really aggressive, but the other nicer way to say that is if you do this correctly, you should end up with h being a common factor of your numerator. It's a good checkpoint for yourself. Because once you factor that out, look what you can do. You can reduce, okay? And now that we've reduced, now let's plug in 0. I plug in 0, I'm going to get 2x plus 0, and I'm going to end up with 2x. Okay. So, Vincent, I have no idea how you had a feeling that that answer would be 2x. You are indeed correct. Okay. I know that sometimes for folks who have perhaps seen calculus before, we know what's coming. We know that this is sort of a very long way to approach this problem. And yet it is important, not just because it's a long way and it's the formal definition, but I think there's a lot of room to practice good algebra. Okay. And good algebra will take you so far in math. It will make so many things much easier for you. Okay. So it's a chance to practice that good algebra. It's a chance to practice that reasoning, like why did we even set this up this way in the first place? Okay. And overall, good problem solving practice, right? Like what do we do if we can't do this way, right? So lots of reasons why it is important beyond the fact that it's the formal definition. I think it's a great chance to build so many skills, okay? All right. We're actually not going to do this part, so don't worry about that part, okay? But how are we feeling with the idea of this process so far? I know we've only seen one example, so can you show how we set up the final answer for this example? Our 2x is the final answer. Yeah. Okay, will we ever have to describe these steps in words? I think I would be prepared to think about how you get from one step to the other. Okay, so being able to explain, not in like super lengthy words, but being able to explain why you made the choices you made is important. Okay.
I have a quick question. I don't know if I missed this, but how does the definition of derivative, why is it over h instead of x plus h minus x? Where does that cancel out?
So if I take our x plus h minus x and I simplify that, I would get something like x plus h minus x. And what happens to those x's?
So it doesn't stay in the parentheses?
Well, if you have parentheses in the front, it doesn't actually impact it. But if you had parentheses at the back end, you would have to distribute a sign. Right? Like here we have a plus sign in the front. So when we distribute that plus sign, we're still going to get x plus h. Okay. And then
So if you want to like input something, it doesn't change.
If you have parentheses around the first part of something and there's a plus sign in front, then it doesn't change.
Got it. Got it.
Okay, and so that's how we get that h. All right. All right, so let's take a look at some more complicated looking questions. Okay. And let's take a look at number 2. Okay, so find the derivative for this function. And now we have a different function. And you can see here very clearly it says formal definition of the derivative. Okay, so you are going to need to show me using that formal definition. If all you do is bring that power down and call it a day, I will say 0 points because you did not follow directions. Okay, so let's get started with this. Let's set up our limit. So we have f prime of x equals the limit as h approaches 0. And I'm going to need f of x plus h minus f of x all over h. And let's keep this second one as a yellow one and the first one as a purple one so we can keep track of what we are substituting in. Okay. And so if we have our limit as h approaches 0, how would I write f of x plus h for this particular function? What would that look like? Good, good, good. Everywhere we see that input, in other words, everywhere we see the input, we replace the input with x plus h. And so we're going to have x plus h squared minus 2x plus h. That's going to be the purple part. And then minus our f of x means minus x squared minus 2x over h. Okay. That's a minus sign. That's a minus sign. And if you don't put parentheses around that second part, you are going to get the wrong answer. Okay. That's my aggressive way of telling you to make sure you put parentheses around that second part so that you will remember to distribute, so that you will get the right answer. Okay. All right. This would be considered a setup. Okay. So if I say set something up, you're just going to leave it like this. But if I ask you to actually find that derivative, now we have to go through, do all the algebra. Okay. You got to be careful about your signs. You got to distribute things as necessary. Okay. It is so, so important that you do those things accurately. And again, this is a great chance to practice that algebra and make it better. Okay. So we'll get up here x squared plus 2xh plus h squared minus 2x minus 2h. That's all from the purple. Minus x squared plus 2x. And that is from the yellow after I distributed that sign. Okay. At this point, things should start to cancel. And once things start to cancel, you should be able to find a common factor of h in the numerator. Okay, so let's see what goes away. X squared and x squared, negative 2x and positive 2x. Those go away. What are we left with? 2xh plus h squared minus 2h over h. This is a good moment to stop and make sure, can you factor an h out of the numerator? Because if you can, then you did it right. If you cannot, then you did it wrong. And then you're going to go back and check your signs. Okay. Two x plus h minus 2. Thank goodness we did this correctly. And now let's try plugging in 0 for h. Okay, so you plugged in 0 for h, you get 2x minus 2. And that 2x minus 2 is the derivative of x squared minus 2x. Okay. So x squared minus 2 is the derivative of, or sorry, 2x minus 2 is the derivative of x squared minus 2x. Okay.
I have a question, Professor. If, since all of those terms are already over h, do I need to show the step where I
Where you need to keep going and not just plug in the value?
No, I'm specifically referring to this last step where you pull the h out of the numerator. All of those terms are already over h. Do I need to actually do that?
Yes. Why wouldn't you do it?
I just mean I don't need to write it. Like 2xh is already over h. H squared is already over h. 2h is already over h. Do I need to factor out the h from the numerator and write that down?
Yes, I would like you to write that down. All right. Any other questions? All right. For the sake of time, here's what we're going to do for the second two pieces, okay? So we're going to practice setting up the derivative for number 3 and number 4, okay? But I think those will be good exercises for you to try on your own to think about, from all that limit stuff that we learned, what strategies still carry over, okay? So in this case, if I'm looking to find the derivative, and this time I have the square root of x, we can say the limit as h approaches 0 of f of x plus h minus f of x all over h. And what would we plug in for our f of x? And what would we plug in for our f of x plus h? All right, so for the purple part, everywhere we see that input, right? Everywhere we see the input, we're going to replace the whole input with x plus h. So we'll get square root of x plus h minus square root of x all over h. And so we have our yellow part here, which is just our function. And then we have the purple part here, which is our function with an input of x plus h. Now, this would be enough if I said, here's the setup, okay? But if you were like, in the privacy of my own study space, I would like to practice this problem, especially if I think my algebra is not very good. I think this is a great place to practice being better at algebra. What strategy might you use here to help us find that limit? Exactly, okay? We are going to apply the idea of a conjugate for the very same reason we applied the conjugate when we were taking limits before with square roots, okay? And so just so we are clear on what that might look like, can someone tell me what I would multiply by? Okay, what is this fancy way of saying 1 that we're going to use to make this problem better?
Square root of x plus h plus square root of x, right?
Perfect. We're going to keep that. We're going to keep that, but we're going to change the sign in between there. Perfect. And we're going to do that in the denominator as well, because we're not changing the problem. Okay. Now this, I think, is an important point to bring up in preparation for Thursday's exam. I have a numerator here, and then I have the denominator. Which one of those should I multiply out?
The numerator.
The numerator, okay? So as weird as this feels, I'm gonna multiply the top out, but I'm gonna be patient and I'm going to keep the bottom the way it is. Exactly, exactly. Okay, so that hopefully will remind you of how you want to approach some limits on the exam 1, okay? But I'll leave this for you to sort of finish. I will tell you that your answer should be 1/2 square root of x. Okay, so if you've got a goal in mind, you want to get to the 1/2 root x. Exactly, Vincent. It's so we can cancel it out later. That is exactly why we're going to be patient. Okay. So if I say setup, I mean, show me your inputs. If I ask you to solve, then I need to see the rest of it. Okay. All right, let's do one more setup here. And that is for example 4. So it says find the derivative for the function f of x equals 9/x. And so formal definition tells me that I should write out this same formula. And we have our input with x plus h, and then we have our input with just x. All right. What is my input going to be when or what is it, the output going to be when I plug in x plus h into the purple part? All right, I see one answer there. All right, I see a few more. Okay, so the key thing we want to note here, it's going to be 9 over the whole thing, x plus h, the quantity x plus h, minus, and then f of x will be 9/x. Okay, so here is our f of x. Here is our f of x plus h. Okay. Now, if I were to solve this, what strategy would I use to find this limit? Exactly. This will take you back to when we looked at complex fractions for limits. Exactly. Find that common denominator. Okay. So even though this looks a little bit different, in some ways it is very similar to those skills that I would make sure you know how to do really well for Thursday's exam. Okay. So I will tell you that at the end, you should have an answer of -9/x squared. Okay. at the end, you should end up with -9 over x squared. I think examples 3 and 4 are really useful ones to practice. Go through, see that you know how to do your conjugates and your complex fractions, okay? The very last one we'll set up is number 5. I think number 5, I want you to view more as a challenge level question, okay? So challenge level meaning I think that it involves quite a bit of algebra, but also a really good place to study if you're like, man, my algebra is not good, it's not where I want it to be. Use this as an opportunity to practice that, okay? All right, so let's just do the setup for this one, noting that it's more sort of challenge level, if you will. While I'm writing this down, if you could go ahead and type into the chat what we might replace f of x plus h with and what we might replace f of x with. Nice, nice. All right, so we're gonna have 1 over the square root of x plus h minus 1 over the square root of x all over h. This is our f of x. This is our f of x plus h. And if we were to think about strategies that we need to solve this problem, what strategies would we use? Yeah, and that's exactly what makes it more of like a challenge level question. We got to think about complex fractions and conjugates. Okay, so it makes this one a little bit of a longer problem. But if you feel like examples 3 and 4 are way easy for you, I would suggest that you practice number 5 just to really shore up on what happens if you have more than one thing. Okay, and then in terms of this, I would probably I think you could do it in any order. I tend to get like rid of the complex fractions first and then do the conjugate, but I think I would play around with that and see which order feels better for you. Okay. Now I know I am over time officially, so thank you so much for your patience here. I'm going to go ahead and stop the recording.